Hello everyone, welcome back to the channel. Today, we are building an advanced SaaS data pipeline animation completely from scratch using GSAP ScrollTrigger and inline SVG layers. We will take a raw layout containing an API node structure and an analytics dashboard mockup and turn it into a dynamic, scroll-driven interactive experience. In this lesson, you will learn how to handle performance optimization for vector paths, initialize hiding states using vector stroke calculations, configure a scrub-driven master timeline with section pinning, and use dynamic function-based properties to animate dashboard charts sequentially. This is a highly valuable skill for modern tech landing pages, so open up your code editor, and let's get straight into the code. We will start directly with our index.html file. In the head section, we first include the Tailwind CSS script via CDN to handle our page typography and layout utility classes. Right below that, inside our internal style tags, we set up our baseline CSS. We style the body to establish a dark theme with hidden horizontal overflow. Then, we create our essential layout wrapper class, named Animation Container, giving it a width of 100% and a height of exactly 100 vertical height units so it locks to the full screen viewport. We also define the SaaS SVG class to ensure our core graphics scale responsively up to a maximum width of 1000 pixels. To finish our styles, we apply the willChange property to our data stream path, chart bars, dashboard window, and nodes. This informs the browser's rendering engine to optimize these specific vector layers for high-performance hardware acceleration before the animation even starts. Moving down to the HTML body, let's look at our structural markup layout. Our first section is a simple full-screen intro block containing our main header text and a scroll indicator. Right under that intro block, we define our main animation container section. Inside this section, we place our vector graphic using an inline SVG tag with a viewbox of 001200-800. Inside the SVG definitions tag, we set up a repeating background grid pattern using a simple path line, and we also declare a feather blur filter named Glow to give our animated lines a premium glowing effect later on. We then draw a full-sized rectangle to render that grid pattern across the entire canvas background. Next in the markup is our source nodes group. Here, we have three separate circles representing our incoming data pipelines, an API circle on top, a SQL circle in the middle, and an S3 storage circle at the bottom, each accompanied by its own labeled text tag. Directly below the nodes, we find our structural paths. We have branch 1 and branch 2 paths that use quadratic Bezier curves to connect the top and bottom nodes to the center. Then, we have our main data stream path, which is a straight line going from x-coordinate 175 to 600, and we apply our glow filter directly to this element. Following the stream path, we lay out our dashboard window group. This group contains a rectangle acting as the window background, three colored circles in the top corner simulating standard browser controls, a title text string, and a clean dividing line underneath the header. Inside this dashboard window mockup, we embed our chart bars group, which contains four distinct rect tags representing quarterly bar graphs labeled Q1 through Q4. To complete our SVG layers, we place a dynamic UI graph line curve and an absolute UI graph.indicator circle that sits right at the final point of that trend line. Finally, underneath our main animation container, we have our closing call to action section that tells the user the experience is ready to scale. Now, let's scroll down to the bottom of the file where we link our JavaScript dependencies. We load the core GSAP library first, followed immediately by the ScrollTrigger plugin script. Let's jump straight into our main script tags to write the logic. Line number 1 is where we call sap.register plugin and pass ScrollTrigger, which instantly gives our animation engine full awareness of the browser viewport scroll behavior. Next, we calculate our path lengths. We select our data stream path using query selector, and we call the native getTotalLength method on it, storing that value inside a constant named path length. We immediately write a sap.set method targeting this mainstream path, setting both its stroke-array and its stroke-offset to that exact path length. This mathematical trick completely pushes the stroke out of sight, leaving it hidden by default. Right after that, we write two more sap.set statements to initialize our UI starting states. We target the dashboard window, setting its transform origin to center, its scale to 0.85, and its opacity to 0. Then, we target our node class circles, setting their scale to 0 and opacity to 0 from the center as well. With our starting states ready, we create our master timeline by assigning sap.timeline to a master timeline constant. Inside the configuration brackets, we open our ScrollTrigger object. We set the trigger to our animation container element. We set the start property to top so the playback engine locks in place the moment the container hits the top of the viewport. We set the end point to +=2500 pixels to give us plenty of scroll depth. We set scrub to 1.2 seconds for a buttery smooth lag effect, pin to true to freeze the section on the screen, and anticipate pin to 1 to guarantee a stable layout lock. Now, we append our step-by-step animations onto this timeline in a strict sequence. First, we write a .to method for our node elements, scaling them to 1 and bringing opacity to 1 with a stagger of 0.15 seconds and a backout ease to make them pop out cleanly. Second, we chain a .to method for our mainstream path, changing its stroke-offset to 0 over a duration of 1.5 seconds using a power 2 in-out curve. We use a relative position offset of -=0.3 seconds so the path begins drawing itself before the nodes finish their entrance. Third, we chain a .to method for our dashboard window selector, scaling it up to 1 and fading its opacity to 1 over a 1-second duration using a power 3 out easing curve, offset by -=0.4 seconds to blend it perfectly with the oncoming data stream. Fourth, we target all the rect tags inside our chartbars group. We pass function-based animation properties, using the index parameter to dynamically assign heights of 140, 220, 170, and 250 pixels respectively. We mirror those exact coordinates on the y-axis to slide them upward cleanly, using an elastic out ease over a duration of 1.2 seconds with a stagger of 0.15 seconds. We offset this by -=0.2 seconds. Fifth, we chain a .to method targeting our UI graph line, fading its opacity to 1 and setting a stroke-array fallback simulation over a duration of 0.8 seconds using a power 1 out curve with a -0.6 second position offset. Finally, we finish our timeline by chaining a .to method on our UI graph.indicator. We transition its opacity to 1 and its scale to 1.4 over a duration of 0.4 seconds. We set yo-yo to true and repeat to 1, which creates a highly responsive pulse effect the exact moment the user reaches the absolute end of the scroll timeline. And that is how you build a premium, scroll-driven responsive data mapping animation using GSAP ScrollTrigger and custom vector structures. By combining layout hardware acceleration, path length mathematical hiding utilities, scrub timelines, and dynamic function-based animations, you can take any static vector design and transform it into a fluid dashboard visualization. If you found this lesson helpful, please hit the like button and subscribe to the channel for more advanced front-end engineering tutorials. If you have any questions about the timeline sequencing or vector property manipulations, leave a comment down below and I will answer you there. Thank you for watching, keep coding, and I will see you in the next lesson.